They say a mirror never lies, but it only ever tells a part of the truth. Hello, you absolute legends, and welcome back to Create Inc. Today, I'd explain the ambiguous shape illusion that you saw in the preface of this video. I'd also show you how you can create the same illusion with shapes of your own choice. Before I start though, I'd like to give due credit to the person who came up with this idea back in 2016, Kokichi Sugihara. I was amazed by what I was seeing when I first saw this illusion, and I was just utterly perplexed. But what perplexed me even more was the comments section. There were at least a couple hundred people who were too smart to be fooled by a cheap trick like this, and how they expressed themselves was the epitome of pure class and unmatched intellect. Like this individual, who explained very eloquently how special effects were involved. You guys are hilarious. Thinking you have it figured out? There is no mirror. Keep pausing and unpausing and you can see the hands are moving at different speeds. Oh boy. There in fact is a mirror. It's just a simple mirror and the hands are most definitely not moving at different speeds. Or this other person who was so secure about their superior intellect that they never felt the need to insult anyone. This is so simple it ducking hurts. And this one? Goody hell. You telling me that no one else has noticed the design of the items being moved? Round circles with square tops with the mirror at the right position? Goody hell. Too many sheeple. Now, God only knows what that explanation was and what it was meant to explain. It might as well have been on any other video and it would make about the same amount of sense. What I'm trying to say here is that there is nothing wrong with a sense of wonder in life. And if you have figured out how a trick is done, dude, chill. Show class and explain it eloquently. It's a trick. It's not the cure for cancer. It's not a Millennium Prize problem. It's just a magic trick. Now, after that rant, before we move on any further, I'd like to tell you that I bring innovative and original content for you. And in an effort to achieve that, I try to do everything from the graphics to the editing and of course the 3D printing and even the music myself. So if you'd like to support my channel, you can check out my Patreon page. But the easiest way to support me would be to hit the like for the algorithm and subscribe to not miss out future content. Before we move on any further, I'd like to thank Dream Polymers for sponsoring filaments for this video. They go by Dream Polymers in India and Sliceworks internationally. These are some of the highest quality filaments I have ever used. I really liked the nice touch of including a Ziploc bag to store your filaments in. They have a great range of high quality filaments, one of which is this lovely wood filament that is sandable and stainable. Now, all that being said, I personally believe that there are different levels of understanding. The first level being where you have a slight idea of how things work, different perspectives and whatnot, about the same level of understanding that I personally possess about cryptocurrencies. And at this level is where most of the comments of that comment section lie. The understanding isn't exactly incorrect, but it isn't enough either. The second level being where you have a good idea of how it works, and now you can recreate the original concept. This is where the understanding would lie for people who originally came up with the explanations, like the Make Anything YouTube channel. The third level being where you have a deeper understanding of what is going on, and now you can not only recreate it, but you also understand the many subtleties that went into it. like soft lighting in this case. Then you can use the same concept to create something that wasn't ever done before. I think that's where the understanding would lie for people like Captain Disillusion, who, by the way, is a criminally underrated YouTuber and helped me understand very clearly how this illusion works. What he did not do, however, was create new illusions, because that's just not his job. And I don't think his explanation of how you can make such an illusion for yourself was good enough. And somewhere in his video, he talks about how focal length makes a difference, and I totally did not understand what he was trying to say. In a certain way, this video is a sort of a response to his video, or maybe an unofficial addendum, but you need not have seen his video to understand this one. The fourth level of understanding would be unobtainium, where you can look at something simple through glasses of different specialties, and eventually you'd just hit a roadblock at the end of a string of whys and hows. Now, putting all that aside, let's move on to the explanation. To understand how this illusion works, we must first understand what vision is. Now, most people might say that vision originates in the eyes, but eyes are merely sensors, collectors of data, so to speak. Vision truly occurs in the brain. Just like an ear can hear, but only the mind can listen. Our eyes merely collect light. The light is translated by the visual cortex of our brain to produce what we perceive as vision. As a computer science graduate, I have started thinking of the mind as a very complex piece of hardware that is constantly processing huge streams of raw data. What is important for us to understand for this illusion is that our mind perceives depth in many different ways. There are different types of cues that our mind uses to understand depth. In the real world that is three-dimensional, we can rely on two of our eyes to produce binocular cues. But a video is just two-dimensional. We have to rely on context cues such as the shadows and the relative size of the objects. What you see on your screen is a two-dimensional projection of a three-dimensional object. The cues you rely on are ambiguous. You might be looking at a square straight on or a trapezoid at an angle. In two dimensions, you can never really know for sure. This is exactly what this illusion exploits. Another important thing to understand is that perspective is linear. What does that mean? To explain it very simply, when an object moves away from us, the points on its body simply start to converge. So if we were to trick someone's brain into thinking that the object isn't moving away, it would simply have to keep getting bigger. And without any context cues, our brain would not be able to figure out how far away the objects actually are. If you combine that with our brain's need to see recognizable shapes and patterns everywhere, you have a masterfully crafted illusion at your hands. For this particular illusion, the position of the camera is very crucial. It has to be kept at a specific point for the illusion to work. The mirror is just a normal mirror, but the objects themselves are shaped in a way that they are neither of the shapes that you see. Just like with the square, that could be a square or a trapezoid, these cylinders just appear to be a particular shape from a particular angle. Now, this is level 1 of understanding, knowing that there is something fishy going on with the shapes. To expand the understanding just a little bit, I chose black color for my prints to hide the cues that originate from lighting and shadows, and I put white paint on top to accentuate the shapes. I have uploaded the STL files for the objects on my Etsy store, where you can get them for a couple bucks if you wish to support my channel, or you can get them for free from my Thingiverse page, no strings attached. But how does one come up with these shapes? How can you make your own shapes into such an illusion? Now we would move on to the tutorial section of this video, where I'd explain how you can make such an illusion yourself using the shapes that you choose. So now I'm going to show you how you can make such an illusion for your own self with shapes of your own choice. There would be a few requirements before you start. First of all, the two shapes that you choose should be a single perimeter, like this. It has to be a single line going all the way across its periphery. Alright. So the second requirement would be that all the corners be rounded off. I have chosen this star-like shape and this circle. These would be the two shapes. One would be visible to us and the other would be visible on the mirror. Yeah. So The second requirement would be that all the corners be rounded off. If they are not, when you print it, it would catch light in weird ways and that would break the illusion. The third and the most important requirement would be, if you were to lay out the space in front of your camera in Euclidean space, the horizontal line being the x-axis and the vertical line being the y-axis, these two shapes should be the exact same width on the x-axis. It is very important, and you would understand why that is while we're doing the tutorial, while we're actually making the illusion, and I would like you to leave the answer down in the comments. So now we are going to save this. We are going to export this as an SVG. Export as SVG, because we are going to import this SVG into Blender. I'm not going to do it again because I've already done it. I already have the shape exported as SVG, but you can go ahead and do it. And after this, we move to Blender. By the way, if you hear some fan noise in the background, please excuse it. It's the sound of my 5-year-old MacBook dying because it has Illustrator, Logic Pro, Blender, QuickTime, and a couple of other apps running at the same time. So we'd start with a journal workflow. Let's delete the default cube. Such is the norm. We would import our file that we just exported. Let's select it, hit S, scale it up just a little bit. Let's go and make sure the origin is at the center. I chose bounds center because the bounds of my two shapes are exactly the same. This illusion works best actually when the bounds both on the X and the Y axis are exactly the same for both your shapes. Let's align it with the center. Let's select them again, object, align objects, relative to scene origin, shift, press down shift and hit X, hit Y. It should now be at the origin. That's good. And we're done with that. You might be seeing that the shapes right now have some sort of a fill in between them. We just want the perimeter. So select the shape, click on whatever button this is. I don't really know. Go to fill mode and none. I'm not really very experienced with Blender. This is, I've only been using it for this video. Fill mode none again. So now we have two shapes that are just the perimeters, and these need to be converted to mesh. Right click, convert to mesh. Same goes for the other one. Select it, right click, convert to mesh. Now we have two shapes that are mesh, that are centered, that we want to use for our illusions. I explained some things to you. I explained that perspective is linear. As things go further away from you, they have to start getting bigger. So if I were looking at the same shape from this angle, I can move this shape further away, further exactly in my line of sight. As long as it keeps getting bigger, I would not notice that it is going further away if there are no other context cues. So the next step for us would be to select a point of view. For this video, for the illusions you saw in the preface, I selected 45 degrees, which worked fine enough, but I think it might have been a better idea to choose a lower angle. Instead of looking down at 45 degrees, somewhere around this, I could have chosen an angle like this. It might have made the illusion a little bit easier to perform, and there was a double reflection on the mirror side. I don't know if you noticed it. A lower angle might alleviate that, double reflection. I'm not exactly sure. So, okay, let's get on with we'd go with a 45 degree angle, and let's see how we're going to leverage what we learned about perspective. So let's just select our two shapes. All right, go to edit mode, select both our shapes, all the, let's stay in vertex mode. See, there are some buttons over here. We'd go to the wire port shading that allows us to select everything that we see. Select it. We are on vertex mode. Hit E, that is for extrude. Hit Z, that locks us in the Z direction, and hit 1. So we have extruded everything in the Z direction by 1 unit. Hit enter. Now we would hit S and 0. That would scale all these vertices down to a single point. All right. They are still different vertices. We have not merged them yet, but they are kind of superimposed on each other. Hit enter again. Now hit G, that is grab. You can use it to move the points around, the vertices around. Hit Z again so that we are confined or restricted again to the Z axis, and type -1. This would put those points back on the origin. Yeah. So this is what we have so far. Now what we are going to do is we are going to hide one of our shapes. Let's hide this one. So we hit the star shape. We are going to move this point 42 units, 42 centimeters in the positive Y direction and 42 units in the positive Z direction. That would give us a 45-degree angle looking down at it. So if you know your Pythagoras theorem, the distance between the object and our point of view would be around 60 centimeters. That is what I was going for. So 42 degrees in the positive Y and 42 degrees in the Z. Let's go ahead. Hit G again. Y 42. Enter. You can see it moved in the Y direction 42 units. G again. Z 42. We do the exact same thing to the other shape. Hide this one and unhide the other one, but now we do it in the negative Y direction. So G again, Y -42, and GZ 42. Yeah. So now things might have started making more sense if you look at it right now. This is the point where our camera would be. This one, point of view looking down at the circle side of things. This is where the mirror would be, the reflection in the mirror, looking down at the star side of things. Let's go to another viewport shading, which is a shaded material. See, I'm not really clear on the terminologies because this is the first time I'm using Blender, very honestly. I'm not very well versed with Blender, but I just learned how to do it so I could create this illusion. So now we have two intersecting point of views. From one angle, it would look like a star, and from the other angle, it would look like a circle. What we have to do now is to extend them further. This has to go beyond this. So let's go back to the wireframe shading. Now select all the vertices here. Hide one of the shapes. Hit GG on your keyboard. G twice. That would allow you to move these vertices along the point of view. You see? I'd undo it. The same thing. GG. Move the vertices up. Press down Alt. And now you can extend it further. Extrapolate it basically. Hit enter. Done with one. Before you start with the other one, please make sure there are no vertices left behind here by trying to select them. Sometimes that happens. I don't know why it happens, but it does. So there are no vertices here. Let's go for the other shape. Hit GG, G twice. Press Alt and extend it further. Let's change our shading back to this second option. Now you can see we have two shapes there that are intersecting. And if you have not yet started seeing it, This is the shape we are interested in, this shape, and this is what we are going to extract from these. Let's go back to object mode, select the two objects. On my Mac it's Command J, the command that we're going to use. We are going to join them. So this is the command. Let's join them, and now they are one shape. Select it, go back to edit mode, go to edge selection, then select one of the edges on either of the two bodies. Hit L. Now you go to face and intersect knife. What that has done is that has created a nice intersection between the two bodies. Go to wireframe shading again and select here, select lasso. Select this, hit delete or X, edges, X, edges, X, edges, X and edges. So this is what you're left with now. From one angle it looks like a star, from the other angle it looks like a circle. But there is a lot more cleaning that needs to be done, and there are some redundancies that need to be removed. We can get rid of this part over here, this, basically this entire shape and this entire shape, we can get rid of it and the illusion would still stay intact. So let's get that done. Please don't worry if it looks a little confusing, because once you start doing it yourself, you would understand what to remove and what to keep. Go by instinct. So now we are left with merely a wire frame kind of thing. Let's remove these parts because we don't need them. I just told you we can get rid of these and the illusion would still stay intact. So let's check if our illusion is still intact. From one angle, it's going to be a star, and from the other angle, it's going to be a circle. That works brilliantly. We can get rid of the other extra edges around. We don't need them. Now comes the important part. We are going to extrude this shape and we're going to turn this into a solid. But before that, let's go to one of the options here. Click on this arrow thing here. I really don't know what they're called. Overlays. Click on the overlays arrow and turn on the normals and make them a bit bigger so you can see. Select everything, go to edges. First of all, hit M and merge everything. Make sure there are no normals. Make this distance very less. 0.0001 works. Hit enter and the normals are gone. It would save you a lot of headache if you don't see those normals. I do undo once just so you can see what happened. So see, there were these normals, but when we merged all the vertices that were very close together, we got rid of those normals. If you don't do that now, you'd have to deal with it later and you'd have to look up a lot of tutorials online on how to deal with normals. Yeah. So once again, go back, make sure you're on the wireframe shading. Whenever you're trying to select everything, make sure you are on this shading, the leftmost button. Select everything, hit E, hit Z, so you are confined to the Z axis, and just extrude it down a little. Go to this shading and make sure that there are no normals inside. These lines that you see coming out, these are normals of each face. you would have to make sure that there are no normals on the inside of the body. Once again, wireport shading, select everything, hit Shift N, recalculate normals, and no normals on the inside. So this works beautifully. Now let's go back to object mode. Select your object, go to modifiers, add modifier, solidify, make it about 0.02 meters, centimeters, same unit, it's all relative, so make it 0.02. This seems thick enough to me, and we are actually done. Now all you have to do is export this as an STL file, or you can just use the 3D printing plugin for Blender. If you don't have it, please download it. It's a very useful plugin. Just go to export, select the folder where you want to export it. Let's do an export. Now let's import this into our slicer and see how it works. Let's import this into our slicer. Here is the shape. The units might be a little bit off. Just make it 1000% bigger. Scale it by 1000%. Now this should be the shape we want it. Since right now the bottom is not flat, just use the cut tool to cut it at your desired height. Keep the upper part, perform cut, and there we have it. Now you can just export it as G-code and print it on your printer. I think you know how to print things. Let's check one last time before we print it to see if it works. From this angle, this is a circle, and if we rotate it 180 degrees, it's a star. It works. And with that, we have come to the end of yet another video. If you'd like to support my channel and my efforts, you can do so on my Patreon, or you can buy some stuff from my Etsy store. If you'd like to follow me on other social media, the link is right in front of you. If you liked the video, you know what to do. If you didn't, the other one is fine. Please leave your inputs in the comments section down below. And until next time, just keep building.